Okay, so here we go. This is Osmocosm Day 3, the final day of our inaugural Machine Olfaction Conference that is coming to you live from MIT and the planet on this October the 30th, 2021. I am aghast at how many wonderful people have spoken already, and we have a fantastic schedule for you today also. First of all, let me introduce myself. Those of you who have been in the conference from the beginning have been paying attention, I think, and I hope you've seen me talk many, many times. So I feel a little bit weird introducing myself again, but my name is Andreas. I'm the director of the MIT Center for Bits and Atoms Label Free Research Group. And the question always arises, why is it called label free? Well, because if your name means nothing, you can do anything. And in my group, we do a lot of things. And we thrive on the variety of things that we do. The cross-pollination of ideas, as Federico just explained, is absolutely key to science. Now, I'm also the president and very proud to lead a fantastic team of individuals that I want to thank right now that are the co-organizers of this conference. And they're also the co-founders with me of the Osmocosm Foundation. The Osmocosm Foundation is behind this conference, as is MIT and the Center for Bits and Atoms. And the purpose of the foundation's existence is to help us develop the ethical standards for the development of this technology and the laws and regulations around it, the technology being the ability to sniff you through a phone, through a watch, through an Alexa or Echo-like thing. Basically, the idea that a camera and a microphone are the eyes and the ears of the world of technology. And what's missing is the nose, and that nose is coming. And the information that is contained in scent, in your body scent and your environmental scent, is so vast and so important that it actually requires some scrutiny. So the team that have been behind this, and I cannot thank them enough. It is just a labor of love from them. For 8 months now, we've been designing this conference. And a great big thanks goes to Carolina Sulic, to Nick Hillal, to Professor Chris Rose, to Lito Yanakopoulou, to Michael Benson, to Dimitrios Ioannidis, to Lyndon Gladhill, and to A.L. Perry from the Media Lab. So let me tell you a little bit about what we're going to talk about today. And this slide is meant to terrorize all academics, all regular academics, because it is so defocused and because it shows us, it's sort of a cross-section through my brain about the various projects. Maybe this is about a third of what has been coming out of my group over the last 17 years that I've been at MIT. And to me, this makes perfect sense. To most other people, it's a big mess. And the point that I'm making here is that science and nature is not divided by textbook, and it's not divided by title, and your degree hangs in your basement or wherever you put it. It does not come into the lab. It doesn't matter really all that much what you already know. What matters is what you want to know. Identify with the unknown. It's a much more powerful thing than the known. So some of the things that you'll see here, and I'll talk about today, is of course the big nose, the littler nose, the very tiny nose that we've created. But we also have created the world's first pain detector by reprogramming a toy that was an EEG. We had trees that could ask for help themselves by powering their own fire sensors. With a postdoc, Philippos Turlomoussis, we created some scaffolding that he can grow stem cells on. We have a project about synthetic cells. And very importantly, we created a technology for ostensibly for Africa. This is actually what brought me to MIT, to create biosolar photovoltaics. That means solar panels out of agricultural clippings, agricultural waste. This went fantastically well academically. I got many awards, and it was published in a high impact journal. And we learned how to stabilize these proteins. However, in real life, nobody used it. And 15 something years later, I will put during the lunch what happened to this idea. The idea got zombified. The idea of using waste for something useful was zombified, did not work in the real world, yet now it's working as something else, where we're building houses out of mushrooms in Namibia. However, it's very important to understand how ideas evolve and how they move through the conceptual space. The technology that led us to be able to stabilize these membrane proteins in contact with electronics is the same technology that allowed us to stabilize another membrane protein called a GPCR, a series of them. These membrane proteins live in your nose right here, and they're what caused the nose, the machine olfactor to be real. So, oh, my Siri is talking. Bye, Siri. So, people ask me, what does my specialize, what do my group specializing? And my group does specialize, even though it's called label free. We specialize in not specializing. Now, it's not a joke necessarily, because the instinct to do the same thing over and over once you get good at something is very, very strong. That's why you see some people in academia publishing 800 papers on the same subject. Now, it's good to be an expert on something. However, it's the impact, at least in my life and in my group, has come from being able to go deep into a subject and have the ability to also let go of it, defocus, and then go after something else. And what you find this way is that a lot of cross-feeding of ideas happens. For instance, look at these devices that Philippos Turlomoussis has created in our lab. These allow you to control the fate of stem cells, and there's a company that he has launched now to do this. This is my homage to young people who came to me. Nicholas Benz from NASA came to me, and he wanted to see if I had any ideas about going to space with my experiments. And I said, well, but space is so hard. And yet a couple of months later, we were, I guess maybe 9 months later, we were actually doing experiments in space with also Dr. David Lai. And this is what I want to talk to you about today. As you walk around, your body is constantly leaking biologically relevant information in the form of odorants. Odorants are molecules that carry the sense of scent. This is an art installation at the Status Center at MIT, where you walk in front of a screen and it shows you sort of what olfaction in my head looks like to a dog who is trained to identify. Look at how these plumes are coming off of my body. You can see my breath, you can see all these things. And in our eyes, we cannot see it. However, in our noses, which our noses are basically a camera for molecules, we can. And this here is a molecular dynamic simulation. This is real data. I'm having some echo, please. This is real data that was done, computed with the help of Michael Skohersky from MIT, where we show what happens when an odorant molecule, these are molecules under 350 Dalton always, a bit of a mystery why that is, it diffuses into a hydrophobic pocket. From here to here, it's 5 nanometers. This is a lipid bilayer membrane that is the outside of olfactory sensory neurons that live in your epithelium, right here in between your eyeballs. After the molecule falls into this pocket, it binds. And I want you to pay attention to this because it is very deep. What has happened is the vibration and the dance that these 7 transmembrane domains of the receptor are doing has changed as a result of binding this odorant molecule. And so has the odorant molecule. It has changed shape and the dance has changed. This is very deep. This is one of the many, many instances of the Heisenberg uncertainty principle in action, which is the same, at least conceptually, as the Gödel incompleteness theorem, and it's all the same as the Newton's third law. Newton's third law tells you that for every action, there's an equal in magnitude and opposite in direction reaction. And this I find very, very hopeful because it tells you that you cannot observe the world without changing the world. In fact, the same goes the other way. The world can never act on you. You can only interact with the world. If you ever feel that, oh my God, what's the world doing to me? Well, you're doing the same thing to the world. It is very hopeful to me. It means that your attention and your interaction with the world, your observation of the world is important. And once you observe something, you've changed it. And this is true of olfaction, maximally so. While looking at someone from a distance, they might not feel that you're looking at them. Smelling something and exhaling it really changes it. It's very powerful. So for a little bit of less deep, but perhaps just as important philosophical realization that I had, I was changing my son's diaper once when he was a newborn, and my 2.5-year-old daughter walks in and she asks me, "What's that smell, Daddy?" And my instinct was to point to the diaper and point to the poop and say, that's what that smell is, to bind an audio signal, my voice, with a visual signal pointing to the diaper. And then my second instinct was to say, oh, it's indole and scatol, and these are the molecules that are associated with the smell of feces. So something came over me and stopped me from doing this very nerdy thing. And instead I said, what does that smell tell you? What's that smell, Daddy? What does it tell you? I don't want to eat it. So suddenly we have this idea that if you ask the right question, which is not what is that smell, but what does that smell tell you, you get a very deep answer from a 2.5-year-old. The deep answer is that the smells make you behave a certain way. Imagine being very, very hungry and then finding your favorite food, only it's located in the world's stinkiest public bathroom. Your appetite just went out the window. So this is the moment where you should realize that perceptual engineering with olfaction is the future. We can do so much with it, and yet we're doing almost nothing. It is both a scary future and a hopeful future. So I will introduce in a minute Thomas Johnson, who is part of the team. He is right there. He will speak right after me. A team that created this paper that has to do with prostate cancer detection by dogs. And the dogs that detected the prostate cancer in this paper became quite famous. It went all over the globe. And it ended up with us actually being part of the reason we're doing this conference. So to switch gears, I want to say that if dogs who have been shown now for 15 years to be the earliest, fastest, and most accurate disease detectors on the planet for any disease that has ever been tried on dogs, this should blow your mind. The fact that dogs can detect COVID in 0.4 seconds with 99% accuracy. The fact that ourselves and other groups have shown that dogs can go as far as 99% accuracy in prostate cancer determination. The fact that we've now shown with a startup called Sentient that as a co-founder has Stephen Thaler and Kostadinous and Wenyi Lee, as well as Bruce Strock, who will talk today, and Wenyi will talk today, and Kostadinous and Stephen also already talked in this conference, as well as Adam Feldman, who's a practicing urologist, and we're very happy to have Howard Sewell as an advisor and George Kung as an advisor. These people have seen the light. They have realized that it is madness to have a dog that can be trained for a few weeks beat our best diagnostic tools out there. This dog, Florin here, can beat the prostate-specific antigen for both selectivity and sensitivity. This should give you pause. And the fact is that the dogs are not magical. They can very easily, and already have to a certain extent, being reproduced. Their noses have been fit into something like this. This is my iPhone 10. You can see how it fits in here. It can fit, you can shrink even more. And the question is, who's going to be brave enough to actually deploy this? So in my lab, we're inspired by this blackboard. This blackboard is what was left on the last day of Richard Feynman's life. This is the last thing he wrote and left it on his blackboard. And what it says on the top left, it says, "What I cannot create, I do not understand." So I flipped this in our group, in my group, and we call it "Build it to understand it." Also important is to not fool yourself. And in building, you'll actually prevent yourself from being fooled by your own biases, because the universe tells you whether you're doing it right or not. So another very good quote is from Alexander Graham Bell, the inventor of the telephone, amongst many other things. And he said many years ago that if you're ambitious to find a new science, measure smell. And he, even though I didn't like it when I started in engineering noses about 17 years ago at this point, he was right. To create something like this, you need to build it, and to understand in building this nose, we have understood that a lot of our assumptions about the nose were incorrect. So we built this. The way that it works is we have a potentiostat that creates a constant potential between two electrodes called the source and the drain. We have 16 channels, and this is the glamour shot of the big nose that went to DARPA. This had 16 channels, and olfactory receptor proteins were immobilized on chips. And then we had an algorithm that ended up being the prescient thing that really helped us win. Now, here we have been shrinking it, and with the support of a big pharmaceutical company who I'm really glad to have worked with, called GlaxoSmithKline, we've managed to shrink this device down to where it could fit inside of a cell phone. Now, why do we want a dog-like device inside of a cell phone? Why don't we want something like a GCMS, something like an analytical tool? Many people are proposing lab on a chip where we're counting molecules by number of instances and name. Well, because the dog does not do that, and the dog does something that no analytical tool can do. What the dog does is, if you train a dog on, let's say, a rose, the dog understands context. So if you then, after training the dog to find roses, you take this dog to the city, what this dog will do is find you the flower store. Even if the flower store has no roses, it will find you the flower store because it realizes that in the context of the background smells of the city, what you're asking it to do is find the most flowery, intense smell. So that would be the flower store. If you take that same dog into the flower store now, and you ask it to find the thing that you've taught it how to find, it will find you the rose, ignoring all the other flowers. Or if there are no roses, it will just sit down and say, no roses here. No analytical tool can do this. No analytical tool can generalize, infer, and decide what is salient based on training, because it is an analytical tool. What it does, it breaks the scent down to components. It tells you what something's made of, not what it smells of. So this is the big difference. And the dogs that have been trained, that have now gone to the Queen of England, where I was very happy to go there with Claire Guest and show off both the dogs and the machines. They have been shown to be very resilient to background sense and to everything else. So to finish up, there's many applications, of course, of these of dogs trained to diagnose disease. But of course, the big thing is to make them fit inside your phone, fit inside your watch, be part of your life such that you can be protected from things such as COVID and early cancer, all these things that we've shown that dogs can do earlier, faster, better, cheaper than any other technology. Now, the question becomes, what does that world look like when anybody can point a phone at each other and know something about their health state? Well, it is probably a very good thing to be able to protect yourself from COVID. Let's say if I want to walk into a bathroom stall and somebody has just sneezed in it full of COVID, I'd like to be able to measure it and say, all right, I don't want to go to this one, I want to go to that one, which is safer. And that's pretty good. But what if I can point it at someone and know whether they have cancer? Well, maybe that's good too. What if I can know whether they're pregnant, what sex they're carrying, what have they drunk, eaten, or smoked? Now it starts becoming very personal, intimate, and scary. And this is the purpose of our conference, largely, is to put it in everybody's head that this technology is coming. It will take a brave company to deploy it, such as Samsung, for instance, who are legendary in their ability to scale up things. It is even thought that they could perhaps do this in 1 year. From the moment that they decide which sensor they want to put into their phones, a year later, there'll be 100 million phones. And imagine a world where 100 million data streams are coming from all over the planet into a central location where these data can be mined and these data can be shared. Now, we should have the copyright of these data. We should absolutely demand for this to become a properly deployed technology, for this to become lucrative for the companies that are going to get behind it. For this industry to launch, we must understand that it's important to have human-centric design, like Federica just told us. That means, first and foremost, learn from the errors of the past. Learn from what has happened with Facebook, with Cambridge Analytica, with all these horrors of spying, of data collection, of lack of transparency, and give the people the confidence to use these devices, knowing that they are first and foremost owners of these data streams because it is their body that's generating it, that they can even make money perhaps with this by instead of sharing your pet or your brunch on Instagram, maybe you want to share your body odor and how it responds to various medicines you're taking, various changes in diet, and then allow people to mine this, allow perhaps big pharma companies to examine it, allow people to track pandemics. This is the way out of the next pandemic and out of this pandemic. The way out is not through more sticks up our noses. The way out is to use this supercomputer that every single one of us is carrying in our pockets and add to it, to its sensor suite, a nose. So this is what I want to leave you with. I am very, very pleased with how this conference is going so far. We will wait for questions from the audience to answer them at the end. And for my next speaker, I would like to introduce Thomas Johnson. He was absolutely key to developing the study of dogs for prostate cancer and integrating it with a microbiome scheme, as well as a GCMS scheme, as well as an artificial intelligence scheme. I kid you not, Thomas, if it wasn't for you, this would have never happened. And I am absolutely thankful and so happy to welcome you here. Thank you for sharing your thoughts with us, and take it away. You have 5 minutes.
Well, thank you very much, Andreas, and I'm very honored to be invited, and certainly very honored for all of your compliments. And it's been such an exciting conference. So I'll just bring up my slides. Just to reiterate, I'm Thomas Johnson from the Prostate Cancer Foundation, and I will discuss canine and machine olfaction in human prostate cancer diagnosis. So the observation that canines have this uncanny ability to detect cancer in humans has a long history, including this small observation in the Lancet that was published in April of 1989. In the decades since this anecdote was published, the medical and scientific literature surrounding the potential of a primary screen for cancers based on volatile organic compounds or odorants or a signature has expanded considerably. At the same time, in the prostate cancer world, interest has grown in discovering novel biomarkers with diagnostic, prognostic, and predictive value in prostate cancer screening. In 1986, the US Food and Drug Administration approved the prostate-specific antigen as an adjunctive test to the digital rectal exam for the detection of prostate cancer. in men older than 50. In 1991, Catalona and colleagues demonstrated that the combination of a serum PSA measurement of greater than or equal to 4 nanograms per milliliter with other clinical findings improved the detection of prostate cancer in a prospective study. So today, now millions of men in the United States are screened with the PSA test annually. However, PSA may also be elevated in the absence of prostate cancer in men with ongoing but benign conditions like benign prostatic hyperplasia or transient conditions like prostatitis. And so a systematic review estimated that if we make a PSA cutoff of 4 nanograms per milliliter, it had a sensitivity of only 21% with a specificity of 91% for detection of any prostate cancer. For a high grade, that sensitivity rose to 51%. However, the low sensitivity means that some men with PSAs of less than 4 nanograms per milliliter will have prostate cancer, but it won't be detected. So to address this urgent and unmet need for patients, the Prostate Cancer Foundation, in collaboration with colleagues at MIT, Johns Hopkins, UT El Paso, and medical detection dogs in the UK, developed the framework of a feasibility study. An early hypothesis of ours was that prostate cancer is an emergent process for canine olfaction detection of volatile organic compounds in urine, possibly years before the PSA elevation occurs. And our aim was to identify odorant signatures that detect malignant disease earlier and distinguish between those patients who will require treatment from those who will not. So we conducted this study to ascertain if biobanked and pathologically well annotated prostate cancer patient urine samples could be shipped to the UK to train and test 2 canine biodetectors, as well as shipped to MIT for GCMS analysis. These samples were also aliquoted for microbiota analysis. Given the limitations in scaling canines clinically, we sought to understand if an artificial neural network together with machine olfaction could replicate the canine predictive response to patient samples. We observed that the training protocol for these dogs had a large effect on their ability to identify samples, and this was consistent with prior research. It is clear from the results that particularly by dog 1, and that was Florin, that learning had occurred during the first 4 positive bias reward system sets. As on changing to balanced reward in set 5, her results were 100%. So the chances of picking the right sample out of 4 3 times in a row is 1 in 64. And so the trained canine as a biological detector demonstrate that they can adapt rapidly if appropriate reinforcement is given. In parallel to the analysis performed by canine olfaction, a subset of the samples were sent for a VOC analysis by GCMS. And so similar to previous studies, we found individual peaks representing VOCs that were elevated or reduced in prostate cancer versus biopsy negative control urine samples. On the basis of predicted probabilities from the final model obtained via jackknife cross-validation, the area under the ROC curve is 0.935, indicating a high discriminative power. So in conclusion, canine olfaction was able to discriminate between prostate cancer and biopsy negative urine samples, and VOC and microbiota profiling analyses showed a qualitative difference between the 2 groups. Furthermore, an artificial neural network was trained to emulate the canine olfactory diagnosis based on GCMS analytical data. Our research indicated that there may be information synthesized by the dogs, to speak to Andreas's point, regarding the nature of cancer that may not be readily identified by a single traditional biomarker analysis, and this may instead indicate that it is an emergent property. Thank you very much.
Thank you, Thomas. That was exactly as I had asked Thomas to be engaging, educational, and rigorous, and he hit all three. So please stay on for the end to accept some Q&A. And next is my distinct pleasure to welcome Dr. Joshua Korzenik. And he amongst our medical professionals cadre, and he wants to talk to us about some serious sniffing around. He is the director of the Crohn's and Colitis Center and an assistant professor at the Harvard Medical School. And we're hoping very much to bring him into this family of people who are sort of the tip of the spear when it comes to using dogs and understanding what they do and help them. And he has some really radical, I think, radically great ideas about dogs and Crohn's disease. Joshua, take it away. You have 5 minutes.
Great. Thank you. 5 minutes isn't too long, but I'm delighted to be part of this. And thank you, Andreas, for inviting me and also to be part of our collaboration, which is really very exciting. So I'm, as Andreas said, a director of a center at Brigham and Women's Hospital where we take care of thousands of people with Crohn's and ulcerative colitis. And one of the why is this not? There we go. Okay. There we go. So what is our problem that we're trying to discuss and take care of today? It's that there's a major need to try to diagnose, particularly people who are having a flare of, we're focusing here on Crohn's, but this could be relevant to many other GI diseases. So first, just to back up just briefly, we're talking about inflammatory bowel disease. What is inflammatory bowel disease? This makes up ulcerative colitis and Crohn's, two diseases where our chronic inflammatory disease of the GI tract, where about 1.5 million in the United States have either one of these, so about 3 million altogether, another 3 million or so elsewhere in the world. Symptoms are fatigue, diarrhea, abdominal pain, and nausea. And one of the problems is that other medical problems can mimic a flare of the disease. So when someone comes to me saying they're having these symptoms, we think they may have a flare of Crohn's, but often they don't. And they're often at home saying, this is a lousy day, I don't feel well. Is this my Crohn's stirring up, or is this something else? And the evaluation of that problem involves blood tests, stool tests, radiologic scans, colonoscopy, as well as other tests. It takes time, it's inconvenient, it delays appropriate treatment, and it's costly. So then there's another problem, Leo. Leo is a good friend of mine. He is a delightful guy, but he really doesn't do that much. He plays, he hangs out. This is his sort of glamour shot when he was a kid, and just last week he turned 1. And what I learned as we got Leo as sort of a COVID dog is how amazing dogs are and how inadequate. We do certain things well, we do other things not so well. So the question is, can we develop a collaboration with dogs that others have done in other fields to be able to apply this to the particular field we're in? And what are the physiologic alterations that we may harness to diagnose Crohn's more rapidly and more effectively in the clinic? And what are the changes? Well, there's GI inflammation. There's changes to the inflammatory infiltrate that line the intestine, cellular changes with neutrophils, lymphocytes, as well as cytokines. They may have a distinct odor, but more directly, there's a change in the microbiome. These are just a couple minor samples and changes, but there's a profound dysbiosis that goes along with Crohn's and ulcerative colitis in remission, and then a different shift and more severe that goes on when there's a flare of the disease. And there's a very significant change to the metabolomic profile, particularly associated with flares. So the metabolomic profiles revealed greater than 2,700 different differentially abundant metabolites in inflammatory bowel disease, including 224 that are significantly elevated in both and 505 that are increased particularly in Crohn's. So there is this broad change in the metabolome. And these changes are likely more profound than the pathophysiological alterations seen in other diseases which dogs have been successful at, such as you just heard about prostate cancer and COVID-19. And this is just a small sort of graph of some of these studies showing that here you can see a broad number of different things, whether it's things such as sphingolipids, bile acids, alcohols, derivatives, some of these which have clearly distinct odors and are differentially expressed in this disease. Now, the focus of much of the work has really been in volatile organic compounds, and there's been some work done in Crohn's in this, and whether that's really the essential marker for disease when we're talking about olfaction or not is really an important question, because dogs aren't going to be selective just for that. And it seems, at least in Crohn's, that lipid peroxidation may be the main mechanism for changing this profile in both Crohn's patients as well as ulcerative colitis patients. And there's a variety of other issues. We're particularly focused in on sulfur compounds, and we think hydrogen sulfide may have a key role in the pathophysiologic changes and inflammatory response. They may not be inflammatory or may not be an autoimmune disease, but that's a separate issue. And there are reductions in things such as short chain fatty acids, which are particularly sort of stinky compounds to work with and may be in another important olfactory clue for what's going on in these diseases. Additional studies have confirmed a capacity to distinguish Crohn's based on VOCs analyzed by LCMS and give an important clue that this may be an effective approach. And so can we identify these and other changes to use them in a practical way as an immediate diagnostic tool in the clinic, or ideally with what Andreas has been doing, could someone have this at home? They wake up, they don't feel great, and they turn on their phone, and then they get some indication of whether they're having a flare or not. So the proposal that's in development, and this is very early, so it's just sharing ideas, is can we develop a tool in collaboration with dogs to rapidly diagnose flares in Crohn's disease? So this would have, and we're in the process of obtaining, hopefully, funding, several steps. The first is really to train dogs at medical detection dogs with Claire Guest, who you're familiar with, to assess the feasibility and also to determine the optimal matrix to utilize for this. The next is to really expand training, and we're bringing in a group from Tufts Veterinary School to bring this to the other side of the Atlantic with an increased sample size and see whether we can do that, whether Leo would be the actual dog or dogs that would be participating. I don't want to be accused of nepotism, so we'll see. And then working with Andreas and his lab to really try to harness both LCMS and other data from dogs to develop algorithms as you've seen, and then a miniaturized device for practical testing, which would be an incredible advance in our field. It would certainly be a wonderful model for others as well. But there is a real practical and immediate need that this would solve that would be a wonderful step forward. And then we really want to take this into the clinic. We want to test the feasibility and accuracy in the Crohn's and Colitis Center. And it's really not meant as a test of dog versus device, but the aim is to bring forward two modalities as practical tools for people dealing with GI diseases. And here is Leo in a visit to the clinic, and we hope that he can be more of a regular member, or at least somebody maybe. We're also very interested in using dogs then as therapy dogs in the clinic and expanding their utility, but that's a separate issue altogether. So who's the team? Certainly, when I came across Andreas's work, I was thrilled and saw a wonderful opportunity for Crohn's, for ulcerative colitis, and for other GI diseases. Claire Guest, who Andreas introduced me to, is really a wonderful collaborator, and we look forward to working with her and her team. And then we have a team here from Tufts that are gearing up to be able to be part of this effort. And then myself and my team, and not to leave out, of course, Leo, who's a bit of a dog with an attitude, but a wonderful guy, and look forward to collaborating with him as well. So thank you very much for your time and delighted to be part of this conference.
Thank you, Dr. Korzenik. So we will, please hold off until the end for questions. There's plenty of them pouring in. And it is my pleasure now to introduce Dr. Bruce Strock. He's a director in the Division of Epidemiology at Brady Urological Institute at Johns Hopkins University. He's a professor of urology, a universally respected member of the field, and I am so honored to call him my co-author in the paper that we have on in +1 on prostate cancer, as well as my advisor and co-founder of a company that is trying to bring artificial dog intelligence into the sniffing out of prostate cancer called Sentient. Bruce, take it away. You have 5 minutes.
Thanks, Andreas. Let me find my, what do we have here? There it is, I think, hopefully. No, are you seeing my, no, you're not seeing my screen yet.
We're not seeing your screen yet, but yeah, it's all right. Matt might be able to help. I have to say
this
that,
is
Hi, Bruce.
different from
So
the usual Zoom link.
no
at the
problem.
bottom of your screen, you see the share screen icon.
Yeah, I click on that.
Yep. Once you click on that, you should have a window that pops up. Just select like your PowerPoint, and then at the bottom right, you'll see a blue button that says share.
I'm clicking on the blue button on the PowerPoint and share, but nothing's happening.
Are you on a Mac?
Yeah.
Okay. Andreas, can we go to the next presenter and come back to Bruce in a few minutes?
Sorry
Well,
about that.
Bruce is the last presenter of this section, but while you're figuring it out, let me just say that what has been, please try and help him if you can. And I'm sure this will get fixed. We have this all the time. You know, this is the Zoom times, the pandemic times. And, you know, compared to what other people are going through, this is the least of our problems. But I'm very impressed with what we've been doing so far. Maybe we can ask some questions while you're figuring it out of the previous speakers. So one question that came through from Stuart Firestein, a professor of olfaction and neuroscience at Columbia. He came in through the chat. He asks, how fast do you think, I think this is for Dr. Korzenik, how fast do you think the microbiome might respond, and how fast can you see these changes to a flare-up?
Well, it's a really good question. We don't have good answers because when we do studies, we tend to do sort of the intervals that we're checking the microbiome is not as close. People are happy to participate, but giving a daily stool sample or something like that hasn't been done all that much. But we think that the changes are relatively rapid. I think that there's the changes in the microbiome, and then there's the physiologic consequences that need to happen. And so I think there's a little bit of a lag, but I think that certainly dietary changes can show changes in the microbiome in a matter of days. And so I think that it can happen quite quickly, but typically these flares are more slow moving processes and that happen over days to weeks. So we think we have an interval which we can sort of identify and intercede pretty quickly. The sensitivity of the ability of dogs and the device to determine whether someone's having a flare is something we need to determine. That's part of our proposed study. So certainly, can we distinguish severe disease? The question also is, can we pick up disease at a very mild end? And so we want to look at that as well and see how well we can differentiate different states of disease.
Yeah.
Bruce, can you please turn on your chat?
Yeah, Matt, I'm trying to send this to you.
Okay, great.
In fact,
Sorry.
Bruce was so very kind to kind of jump in at the last minute. He was scheduled to talk at 11:15. This is perhaps the universe telling us that the original scheduling was correct. So perhaps unless Bruce wants to go without slides, which is an
Okay,
option.
Matt, it's coming to you.
Okay. Unless Bruce, it's up to you. You can try and figure this out and speak a little later, or we can.
Yeah, I mean, I can start without slides, I guess.
Okay, go ahead. Then let's hear from Bruce, and then we can all stay for the Q&A. And I'll give Bruce another chance at his originally scheduled time because we feel bad about yanking him around the last minute. You're the only one that happened to. I'm so sorry about this. So okay, Bruce, go ahead.
So Matt, will you be able to just put it up without me having to hit screen share?
Yes, once I receive them, yes.
Okay, should be on its way. Okay, well, I'm going to talk about some things that I'm really not an expert in. The title of my talk, which hopefully you'll see very soon, is Cancer Metabolism Outrunning Evolution, ? And I'm not an evolutionary biologist. I'm not a smolosopher. I'm an epidemiologist, as Andreas told you, and I focus on mostly prostate cancer and biomarkers. But I like to also think about how did some of these things happen. And what I want to do is get you thinking about metabolism and our bodies and how they've changed over billions of years, billions, millions, down to the present.
And you did talk about the 5 design principles. And I want to ask, what is it that keeps most of technology from actually following those very sensible design principles? We see things like with a Windows operating system, which keeps getting worse. We see smartphones that keep getting worse now. They seem to have peaked, and now our ability to not only feel comfortable with what they're doing, but also to have ownership of the data that's on them, and also have ownership of when and where we want to upgrade them, when and where the battery will run out, all these things. To a certain extent, we understand this as business tactics, but surely there must be, I mean, you are at one of the world's preeminent companies, surely there must be a movement to fix this. And surely there must be a business understanding that to take care of your customers is what underpins longevity for a company. Can you speak a little bit about the challenges you faced in bringing human-centered design? What a great answer, and what a great question that just came in from Carolina. She asks, I wonder if it's not time for environment-centered design. And I want to put it out there that the two things are the same. You can't separate the human from the environment. If you're disrespectful to your environment or to other humans, then you're disrespectful to the human. It's not really all that different. So, but perhaps it is different in people's minds. People who think that, oh, I have to make money by destroying the environment. Well, that is a short-term solution. In the end, you're going to be essentially pooping in your own home. I have one more question for Federico again. So we've all seen the power of the dogs. We've all seen that the technology is available. In the first couple of days of the conference, we had a lot of nose makers and nose companies. And the truth is that a lot of companies have died in this field. Over the 30 years, I've seen it's littered with the bones of olfactory or machine olfaction or electronic noses. The bones of Silicon Valley, the Silicon Valley is filled with the bones of such companies. And it's unclear why this is happening. And perhaps what we should take a lesson from is from history. So cameras were always very useful, okay? And they were big, and then they get smaller and smaller. And then finally they became digital, and finally they became part of this. And then somehow photography became a whole new thing. Everybody now is a photographer. As soon as the camera found its platform on the smartphone, the world changed. The world of tourism and dating and influencers, okay, but also the world of politics. I mean, wars have been fought because of imagery that has been done. So the world suddenly changed. We also have cameras now on cell phones that can diagnose which strep throat you have. We have cameras that are filters that are marketed to doctors that can diagnose diseases as serious as cervical cancer. The question that I want to put to Federico and to the world is this: what will it take for one of these large companies to deploy the first nose phone in a large scale? We do have nose phones here and there. There's the S61 by Caterpillar that is very successful. However, it's a one-off. What would you think will it take to spark this and to bring this future in? Is it about trust? Is it about, because it's certainly not about technology. The technology has been tried and validated, and it's definitely not about the vision. We know that the dogs can do it. We know that the technology can fit. It's something like aviation. We know that the birds could fly. We knew that the heavier than air flight was possible, yet it took the Wright brothers and then it took Charles Lindbergh to actually make commercial aviation possible. So what will it take to bring nose phones, medical nose phones, that will solve the next pandemic and this pandemic? What do you think will take?
Yeah, such a great question. I mean, I will have the same one. I think it takes courage. It takes trying really to make sure, like, because there are phones that are already there. So usually innovation comes by waves. And you know, that expand and enlarge, and by ripple effect, then there is a an immediate acceleration. So I think we are no longer in the small incremental acceleration, but it's really in a disruptive way. And I think hopefully we're not far from that. I think that could be a very interesting area of exploration, and having a smart nose on a phone or on a personal device, I think can definitely create a revolution that we can only see partially how this will impact human societies and our behaviors and health and way we communicate. I think, Carolina question about environmental centered design, and you have definitely, Andreas, provided an initial response, and I agree with you. When we talk about human-centered design, I also have mentioned human-centered plus humanity-centered, planetary-centered design. Human-centered design can be very produce very counterproductive effect. So that's it. So anyway, I really hope that we can reach a point where we scale up this technology, learn, and really explore tech for good in a unique way.
That's fantastic. Bruce just puts it out there to say, why don't we call it life-centered design? That encompasses everything, right? The Earth is alive. If you're damaging life on any level, then you're damaging yourself. One last thing I would like to say, and then I have a question for Thomas, is this, that I'm inspired by the history of cameras on the smartphone, and even on the cell phone before the smartphone. Cameras existed as very big devices that were very high resolution. We had SLR cameras, and then suddenly somebody put it on a Nokia phone, which was even before the smartphones. And it was a really poor camera. Okay, I remember having that phone, and I remember thinking, what the hell? I mean, this is just so poor compared to everything else. I was into photography, and my SLR would take 12 megapixel pictures, and then this thing would take like 480 by something. And then suddenly, the fact that that existed, the next manufacturer put a little bit better camera and a little bit better camera. And before you know it, we have phones now that can take pictures that are better than any large devoted camera. I think we learned from this history, and we realized that it takes some brave company to do the first one, even if it's not great, so long as the correct functionality is there, meaning that it has something useful to provide to you. And that means that we need an app marketplace. And the app marketplace for people to write apps on top of a sent data stream doesn't exist because there is no sent data stream. The one-offs here and there are not connected to the internet, the smartphones that can smell the world now. Once a company such as Apple or Samsung or even Google, because they're not really well known for their smartphones, but perhaps this is their way in. Once they put it up there, I think a race will happen, and we will all be better off for it. Now, the trick is it requires a brave step forward. And I think what we learned also from Michael Benson is that the companies are likely very smart about this, and they realize that it will take hundreds of millions of dollars of investment to get there, to get to 100 million cent phones in 100 million pockets. Why take that investment unless someone else is doing it? And why take it if we're not sure that the public will like it and the public will buy it? What if it's just a gimmick? And this is a real danger. If the public is afraid of this, if the public isn't sure that this is not going to spy on them, if they can't understand what it's for, if they can't understand how to even use it, then it's a real danger. So we are working really hard at the Osmocosm Foundation to make sure that the ethical standards are there. And they will realize by flipping one bit, we learn from history, okay? So as not to repeat the mistakes of the past. Let's not run into the same iceberg twice, okay? Let's launch the Titanic and not run into any icebergs if possible, but definitely not the same iceberg. So what we're saying is this: let's recognize that sent data is owned by the person who generated it, meaning my body. That means that just like the pictures that are on my phone cannot be stolen by the phone manufacturer, cannot be stolen by Facebook or others and used for advertising or whatnot. Similarly, we start by establishing laws that say, and we had a whole legal cadre yesterday talking. We had 2 hours of a moot court competition adjudicated by actual practicing judges here in Massachusetts and argued by two groups of law students, where we discussed this idea of who owns these data. They're so powerful. So I think that once we get ahead of this and we say, similar to what we did for the genomic data, we say, look, there's laws in place that will not allow you insurance companies and others to abuse these data. You will be the first owner and you will be opting in instead of opting out of sharing. Then that's the way forward to, first of all, assure the users that it is their data and it is encrypted and it is theirs first. If somebody steals it, then they have a recourse to it to be made whole. And if they choose to share it, if they choose to annotate it, then great. They can even make money with it, because as opposed to picture data that gets less valuable with time, sense data gets more valuable with time. If you record your body odor over weeks and months, then you can look back and say, oh, you know, I got sick on Monday, but back last Friday, this is what my body was smelling like. Therefore, I can now prevent this from happening. Things like this. This is the future that we envision. So we have a couple more minutes to do this Q&A, and I want to ask one question of Thomas. And Thomas, you are sort of straddling the worlds of the Prostate Cancer Foundation and medicine and this canine and machine olfaction and microbiome. What was the hardest thing, I think, that you faced in organizing all of us cats and herding us and kind of integrating the stream of information? Because the paper that we co-wrote is so wide in scope. I was at some point losing my losing my hope there, and you brought us back. So Thomas, tell us how you managed and what were the biggest challenges you faced?
Well, maybe I'll just start with, I think, one of the biggest benefits and then speak to a challenge. But really, and it kind of works both ways, but the paper kind of became a more sprawling but related enterprise. So when we included other partners of yours, Andreas, and were able to do analysis or construct an artificial neural network, I'm sure that was probably to some extent always envisioned. And it certainly is, it speaks to the power of the study that it was so multidisciplinary, you know, and I think it is challenging to kind of reorient the framework in some way. But I think all the individual participants contributed substantially. The biggest challenge, maybe not so glamorous, it's not a scientific challenge in particular, but fundraising certainly is first and foremost a priority for us at the Prostate Cancer Foundation. So finding funds to appropriate for science like this relies on, to some extent, having a donor interest and keeping donor engagement and donor stewardship. So certainly it is a very compelling idea. I think it has a lot of purchase in the public. People are often quite engaged with medical stories where there's a dog that is offering some kind of clinical utility, as you mentioned in your presentation, with kind of media highlights. And Claire certainly has gotten a lot of focus for her work. But translating that into even small donations or to something a little bit larger has been a challenge. But certainly it's something that we are still thinking about at PCF. And I know we haven't mentioned it here, but we have kind of plotted the outlines of a phase 2 study. Bruce has very kindly plotted the outlines of this phase 2 study for us. And so just kind of contingent on that influx of interest from a donor, you know, we certainly are very interested in moving forward with phase 2 still.
And I would be remiss to not highlight and really hammer it in that everybody here should donate to pcf.org. It is a fantastic organization for funding science. Hundreds of millions of dollars to this point has been given. And to a large extent, it is due to this organization that we even have as much of the treatments and diagnostics as we do for prostate cancer. Untold numbers of lives have been saved and improved. And I love their motto. Their motto is curing together. They're not mealy-mouthed about it. They're not a nickel and diming us. They're going after cures, and they understand that it is about togetherness of the researchers, the patients, their families, the doctors, the clinicians, the physicians, the people doing the diagnostics, and now even the dogs. Okay, so curing together is the way. Humanity works best when we work together, and that's how we solve problems. So I think we're at the end of our first session. Thank you very, very much to all the speakers. And we have a lot of comments that will be in the chat. And we will reconvene at 11. We start now with the ideathon sharing, which I will let Carolina explain in a minute. This is for those who have created content and want to share it. Please stay if you can. It is a low stress environment. And then we reconvene with Bruce starting us at 11:20 or 11:15 rather. And Bruce, I can have your slides and share them for you. If that's the problem, you can email them to me and you can tell me next slide. And I'm so sorry that it didn't work earlier. We tried to get you up earlier, but in fact, we should have kept you where you rightfully were. And for the next session, we have an hour's worth of Ideathon led by Carolina and Chris. And then we have Bruce Truck, who I already introduced. Then we'll have a chat with Dr. Adam Feldman, who is a practicing urologist and also co-founder of Sentient. And then we'll have a talk by Dr. Simi Foster, who is an MD PhD, a neuroimmunologist, and she'll talk to us from Mass General Hospital and Harvard Medical School about olfaction and neuroimmunity sent as an adjuvant in vaccines and mental health. And finally, we'll have a fantastic presentation, I want to say, by Cecilia Roque, who's an assistant professor in Universidade Nova de Lisboa. And she's going to be talking to us about seeing the unseen. They have a technology I'm super excited about that involves liquid crystals and sensing olfaction. So please stay for the Ideathon and join us again for lectures in an hour. So Carolina and Chris, please take it away.